have already studied about the circulation of ocean currents in the Pacific Ocean. Today, we will study about the circulation of ocean currents in the Atlantic Ocean. We will first study about the northern half and then we will study about the southern half of the Atlantic Ocean. In the North Atlantic Ocean, we have many important ocean currents. The first important ocean current is the Gulfstream. Now, the Gulfstream is a warm current. See, it is marked with red. So, it is a warm current. Why it is a warm current? Because Gulfstream originates in the torrid zone. So, it originates in the torrid zone. Now, since it originates in the torrid zone, therefore, it is a warm current. Now, where does Gulfstream originate? Gulfstream originates in the Gulf of Mexico here. From here, Gulfstream travels along the eastern coast, along the northeastern coast of North America. See, Gulfstream extends towards Europe. Now, when Gulfstream travels along the northeast coast of North America, it has a very significant impact on this coast. Now, we will study about that impact. In our previous slide, we saw that Gulfstream flows along the northeastern coast of North America. Now, when it comes along the northeastern tip of North America, it combines with a cold current. Now, we have already studied that Gulfstream is a warm current. So, now we will see what happens when Gulfstream combines with a cold current. Now, Gulfstream is a warm current. So, the air above the warm current is also warm and carries moisture. Whereas, the air above the cold current is cold and dry. That is, it does not contain moisture. So, the moisture present in the warm air when combines with the cold air of the cold current condenses into tiny droplets. That is how fog develops at the confluence of warm Gulfstream and a cold current. That is, when a warm current and a cold current meet, fog develops. And why fog develops? Due to condensation of moisture present in the warm air, that is the air present above the warm current. And when it combines with the cold air present above the cold current, a fog develops. Now, we will study about another important current which is prevalent in the Atlantic Ocean. We studied that Gulfstream originates here in the Gulf of Mexico. Then it flows along the northeastern coast of North America like this. Now, when the Gulfstream reaches the northeastern tip of North America, that is here in the Newfoundland region, it gives birth to another warm current. Now see, the Gulfstream that had originated in the torrid zone had already reached the temperate zone. See, temperate zone lies between the Arctic Circle and the Tropic of Cancer. So, Gulfstream has already moved in this zone, that is in the temperate zone. Now, we have learned that in the temperate zone, a planetary wind called the westerlies is very prevalent. Now, westerlies flows in this direction, that is from southwest to northeast. So, under the influence of westerlies, the Gulfstream moves in this direction and it gives birth to another warm current. The name of that current is the North Atlantic Drift. Now see, the North Atlantic Drift again flows towards Europe. And when the North Atlantic Drift reaches the western coast of Europe, it branches into two. The first current flows northwards towards Norway, and the other part flows southwards as the cold Canary Current. Has a very significant influence on the country of Norway. Now we will study about that influence. Here you see that the North Atlantic Current flows southwards as a cold current. But this is very surprising because North Atlantic Drift is a warm current. Then why does it give birth to a cold current? which is the Canary Current. Well, see that this is the temperate zone. Now, temperate zone is relatively cooler than the torrid zone. So, here we have an upwelling of cold water from deep oceans, and due to this upwelling of cold water, the North Atlantic Drift gives birth to a cold current, and the name of that current is the Cold Canary Current. So, see that here the North Atlantic Drift flows towards the country of Norway. Now, when the North Atlantic Drift flows towards the country of Norway, it has a very significant impact on that country. We will study about that impact. As I have mentioned earlier, North Atlantic Drift being a warm current when flows towards the country of Norway, it does not allow the port of Norway to freeze even during winters. So, under the influence of the warm North Atlantic Drift, the port of Norway remains ice-free even during winters, and therefore the port is navigable for the ships. This is actually economically advantageous for the country of Norway. Why? Because since the port is navigable, it supports trade and other commercial activities in the country. So here we have learned that North Atlantic Drift, which is a warm current, does not allow the Norway port to freeze, and therefore the Norway port remains navigable even during winters. Now we will study about another important current. If you remember, I have already mentioned that when Gulfstream comes here in the northeastern tip of North America, it combines with a cold current. The name of this cold current is the Labrador Current. Now, Labrador Current is a cold current. See, it is marked with blue. That is, it is a cold current. Now, why Labrador Current is a cold current? The Labrador Current is a cold current because it originates here in the Arctic Ocean, and then it flows along the western coast of Greenland and travels further southwards. Then it flows southwards and comes to the eastern coast of Canada. Here, when it comes to the eastern coast of Canada, it meets with the Gulfstream. And here we have the confluence of a cold current, the cold Labrador Current, and a warm current, that is the Gulfstream. Now, we have already learned that when a warm current and a cold current meets, what happens? Fog develops. Now, we will learn what else happens when a warm and a cold current meet. Now, when the warm Gulfstream and the cold Labrador Current meet, a fishing ground develops. The name of that fishing ground is Grand Banks. See, when the warm Gulfstream and the cold Labrador Current is meeting, here a fishing ground has developed. We can see from the map that Grand Banks is located near Newfoundland. So, in this region, when the warm Gulfstream and the cold Labrador Current meet, a fishing ground develops, and the name of that fishing ground is Grand Banks. Now, why a fishing ground develops at the confluence of a warm current and a cold current? Now, we know cold current is heavier. So, when it comes from deep ocean, it brings planktons and nutrients from deep oceans to the surface. So, the fishes get food and thrive rapidly. Therefore, a rich or a prosperous fishing ground develops at the confluence of a warm current and a cold current. Well, this is a merit of the cold Labrador Current. But there is also one disadvantage of this current. What is it? We will see it. Now, we know that the cold Labrador Current originates in the Arctic zone, which is a very cold region. So, when the cold Labrador Current comes down from the Arctic region, it brings icebergs along with it. These icebergs are actually huge chunks of ice which makes navigation difficult for the ships because the ships cannot find their way in the middle of these huge icebergs, and therefore often icebreakers are required to break these huge chunks of ice and make navigation possible. So we learned about one merit of Labrador Current, that is when the cold Labrador Current meet with the warm Gulf Stream, a fishing ground develops. And we also learned about a demerit of a cold Labrador Current. What happens is that cold Labrador Current brings down icebergs from the Atlantic Ocean, which makes navigation difficult. Now we will study about the complete circulation of ocean currents in the North Atlantic Ocean. So before we proceed with our lesson, can you help me to answer this question? What makes navigation difficult for ships? Is it the iceberg, an ocean current, plankton, or fish? Well, we just learned that icebergs make navigation difficult for ships. Now we will study about the complete circulation of ocean currents in the northern hemisphere of the Atlantic Ocean. Now the circulation in the northern half of the Atlantic Ocean begins with the North Equatorial Current. Now North Equatorial Current is a warm current which originates in the torrid zone near equator. This warm current flows from east to west and then it deflects to the right. This deflection happens due to Coriolis effect caused by Earth's rotation. Now just see that North Equatorial Current is marked with red, which means that it is a warm current. Now why North Equatorial Current is a warm current? This is because North Equatorial Current originates in the torrid zone, which has very high temperature, and therefore North Equatorial Current is a warm current as it originates in the torrid zone, and then it flows from east to west and then deflects to the right. Now we will see what happens when the North Equatorial Current deflects to the right. Now, in our previous slide, we saw that the North Equatorial Current originates in the torrid zone and then moves from east to west and then deflects to the right. After deflecting to the right, it comes here in the Gulf of Mexico and then it gives birth to another warm current, and the name of that current is Gulfstream. Well, we have already studied about Gulfstream. Gulfstream is a warm current which originates here and then it flows along the northeast coast of North America. Now here also Gulfstream is marked with red. Why so? Because Gulfstream is a warm current because it originates from a warm current which is the North Equatorial Current. Now we will see which ocean current comes next. Gulfstream originates in the Gulf of Mexico and flows along the northeast coast of North America. See, here the Gulfstream has already reached the temperate zone. So, again in the temperate zone, westerlies is prevalent, and under the influence of westerlies, the Gulfstream gets deflected in this direction and gives birth to another warm current, and the name of that current is the North Atlantic Drift. So here when Gulfstream has already reached the eastern coast of Canada, it comes under the influence of westerlies and gives birth to another warm current. The name that current is the North Atlantic Drift. Now see, the North Atlantic Drift flows towards the western coast of Europe. Now we will study about the next current in the circulation. So when the Gulf Stream reaches the eastern coast of Canada, it meets with a cold current. The name of that current is the Labrador Current. Now, Labrador Current, as I have mentioned earlier, is a cold current which originates in the Arctic zone and then it flows along the western coast of Greenland and connects with Gulfstream here in the eastern coast of Canada. And we have seen that when the warm Gulf Stream and the cold Labrador Current meet, a fishing ground develops. Apart from that, fog also develops at the confluence of the warm Gulf Stream and the cold Labrador Current. Now, here the Gulf Stream, under the influence of westerlies, flows as the North Atlantic drift towards Europe. Here, when the North Atlantic drift flows towards the western coast of Europe, it travels northward and gives birth to another warm current, and the name of that current is the Norwegian Current. So, when the North Atlantic drift reaches the country of Norway, it gives birth to the Norwegian Current. Now see, the Norwegian Current is also marked with red. Norwegian Current is a warm current. And why it is a warm current? This is because Norwegian Current originates from the North Atlantic drift, which is a warm current, and therefore Norwegian Current is also a warm current. The North Atlantic drift also has a southern offshoot. We will study about that current. So, as I have mentioned earlier, the North Atlantic drift actually branches into two parts when it reaches the western coast of Europe. Firstly, it travels northwards as the Norwegian Current, and it flows southwards as the Canary Current. Unlike the northern offshoot, the Canary Current is not a warm current, rather it is a cold current. And why Canary Current is a cold current? Well, I have already mentioned that Canary Current is a cold current because here it originates in the temperate zone and temperate zone is relatively cooler than the tropics. So here we have an upwelling of cold water from deep oceans, and due to this upwelling of cold water, North Atlantic drift gives birth to a cold current, and the name of that current is the cold Canary Current. Now see, the cold Canary Current further flows southwards and connects with the North Equatorial Current. And the gyre in the North Atlantic Ocean gets completed. So the circulation in the North Atlantic Ocean begins with the North Equatorial Current, which gets deflected to the right and gives birth to Gulfstream. Then Gulfstream, under the influence of westerlies, flows towards Europe as the North Atlantic drift. Now here, when the Gulfstream reaches Canada, it connects with a cold current, that is the Labrador Current. And when the North Atlantic drift reaches the western coast of Europe, it branches into two parts. The northern part is the Norwegian Current and the southern part is the cold Canary Current. The cold Canary Current finally flows southwards and connects with the North Equatorial Current. And the circulation in the North Atlantic Ocean gets completed. Now just see that the ocean current flows in a clockwise direction, from North Equatorial Current to Gulfstream, then to Atlantic Drift, and then finally the cold Canary Current connects with the North Equatorial Current. So here we find that a clockwise circulation of the ocean currents. We have already learned that the ocean current follow clockwise pattern because of the Coriolis effect caused by Earth's rotation. So, due to Coriolis effect, the ocean current flows in clockwise direction in the northern half of the Atlantic Ocean. Now, we will study about the circulation of ocean currents in the southern half. The circulation of ocean currents in the southern half of the Atlantic Ocean begins with the South Equatorial Current. The South Equatorial Current, just see, is marked with red, which means that it is a warm current. It originates in the tropics near equator, and then it flows from east to west. Then it gets deflected to the left due to Coriolis effect caused by Earth's rotation. Now we will see what happens when this current gets deflected. In our previous slide, we saw that due to Coriolis effect, the south equatorial current gets deflected and it flows southwards as the Brazilian current. So, the south equatorial current after deflection flows towards Argentina as the Brazilian current. Now, Brazilian current is marked with red, which means that it is a warm current. And why it is a warm current? This is because it originates from the south equatorial current, which is a warm current, and therefore both are warm currents. Now, here you see that when the Brazilian current has reached Argentina, it is already in the temperate zone. See, it is between the Tropic of Capricorn and the Antarctic Circle. So here in this map we can see two cold currents, the west wind drift and the Falkland current. In the circulation of ocean currents in Pacific Ocean, we have already studied about the west wind drift. West wind drift is a cold current in the Southern Ocean and it flows in a straight line. And why so? Because in the Southern Ocean we have no land mass to obstruct its way, and therefore the west wind drift flows straight. And west wind drift is a cold current. The Falkland current is an offshoot of the west wind drift, and therefore Falkland current is also a cold current. Thus the Falkland current also becomes a part of this circulation. Now we will study about the next current in the circulation. The next current in the circulation is the South Atlantic current. When it reaches the coast of Argentina, it is already in the temperate zone. So, when the Brazilian current and the Falkland current combines, they give birth to a cold current, and the name of that current is the South Atlantic current. So, near Argentina, the Falkland current combines with the Brazilian current and gives birth to a cold current. The name of that current is the South Atlantic current. Just see in the map that the South Atlantic current has been marked with blue, which means that it is a cold current. And why it is a cold current? It is under the influence of an offshoot of the west wind drift, which is the Falkland current, and therefore the South Atlantic current is also a cold current. Now just see that the South Atlantic current flows in this direction, travels towards the southwestern coast of Africa. Now we will see what happens when it flows towards the southwestern coast of Africa. So in our previous slide, we saw that the South Atlantic current flows towards the southwest coast of Africa. Now it travels in this direction. This is because of the presence of westerlies in the temperate zone. Now, westerlies is a planetary wind which is prevalent in the temperate zone. So, under the influence of westerlies, the South Atlantic current gets deflected and it flows in this direction towards the southwestern coast of Africa. Here, then it flows northwards as the Benguela Current. Benguela Current has been marked with blue, which means that it is a cold current. And why Benguela Current is a cold current? This is because it originates in the temperate zone and from the South Atlantic current, which is also a cold current, and therefore Benguela Current is a cold current. The Benguela Current finally travels northwards and connects with the South Equatorial Current, and therefore the circulation in the South Atlantic Ocean gets completed. The circulation of ocean currents in the South Atlantic Ocean begins with the South Equatorial Current. The South Equatorial Current flows from east to west and then gets deflected to the left. After deflection, it flows as Brazilian Current towards Argentina. And here, when it reaches Argentina, it connects with an offshoot of the west wind drift, and the name of that offshoot is the Falkland Current. And then it gets deflected and flows as the South Atlantic Current. Here, under the influence of westerlies, the South Atlantic current flows northwards as the Benguela Current. The Benguela Current finally combines with the South Equatorial Current and completes the circulation. Here you see that the circulation of ocean currents is in anti-clockwise pattern. And why so? The circulation of ocean currents is in anti-clockwise pattern because of the Coriolis effect caused by Earth's rotation. So, today we have studied about the circulation of ocean currents in the northern half of the Atlantic Ocean and then in the southern half of the Atlantic Ocean. We saw that in the northern half of the Atlantic Ocean, the ocean currents follow clockwise pattern, and in the southern half they follow anti-clockwise pattern. The ocean current follow these pattern due to Coriolis effect. We also studied about three important ocean currents in the Atlantic Ocean. They are Gulfstream, the North Atlantic Drift, and the Labrador Current. And finally, we studied about the complete circulation of ocean currents in the southern hemisphere of the Atlantic Ocean. In our next video, we will study about the circulation of ocean currents in the Indian Ocean. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.